Section 5 deals with solving trig equations, and essentially solving trig equations are dealing with equations that have any of our trig functions in them. We're going to look exclusively at functions that just have the trig functions involved and not combinations of trig and logarithmic or exponential or any other type of function. Now I think as we take the step from inverse trig functions into solving trig equations, we have to be careful of this right here. Because as we go through and solve, if you look in our first example as we come up, at one point our last step is going to be the sine of x equals 1/2. And if we're solving this trig function, we're looking for x, and so then we take the inverse sine of 1/2. And so now we have to be careful about how our inverse trig functions were defined versus what we're looking for when we solve an equation. When we solve an equation, we're looking for every value of x that would make this true. And so here's our sine function up here. Here's a graph of sine. The red line represents the 1/2 mark, and as we know, if this goes on to positive and negative infinity, there's an infinite number of places where the sine of x equals 1/2. And so our solution needs to refer to all of those possible solutions. Whereas when we just take the inverse sine of 1/2, by definition of the function, inverse sine function, this would be the only possible solution. And so we have to be aware that when we're solving trig functions, we're looking for all possible solutions, not just the solution in the fundamental domain. All right, the first one, 2 times the sine of x minus 1 equals 0. Just because there are trig functions in there, we still treat them like algebraic expressions. In fact, I think one of the things that we should do is we should think of our trig function as being just one big variable. So essentially we could think of this as being solving 2x minus 1. So the first thing we would do is add 1 to both sides. And so we would have 2 times the sine of x equals 1. Divide by 2. And there's our sine of x equaling 1/2. Oops, 1/2. And so now we have to ask ourselves, where is the sine equal to 1/2? Or where is the inverse sine, or what is the inverse sine of 1/2? And so we know from our unit circle that that's going to take place at, so in other words, x equals pi over 6. But we also know there's one other, and so we're looking for all possible solutions. And so if we go to our unit circle, where our y-coordinate is 1/2, there's pi over 6 over here. The other place is 5 pi over 6. And so there's our two solutions in our first cycle around the unit circle. Now, how do we account for every other solution? Well, we know we can get back to this position. All the other solutions are going to be coterminal angles with these two solutions right here. And so all we need to do is add or subtract, because we could go in the negative direction or positive direction, and we're just going to add or subtract multiples of 2 pi n. And what we need to remember is n equals some integer. And so this is the general notation that we use in terms of presenting our solutions for trig functions. We list the ones that are in the first cycle of the unit circle, and then we add 2 pi n. And why 2 pi? Because these are periodic functions with a period of 2 pi. They repeat. The solutions repeat every 2 pi. And so that's the significance of that part of the statement. Now as we look at more functions here, we're going to see that we're going to deal with a lot of situations that we dealt with in algebra. And so I always look at these as algebra problems. So a tangent squared of x minus 3 equals 0. So just think of this as something squared minus 3 equals 0. And so first thing we do is add 3 to both sides. And so we get tangent squared x equals 3. And now at this point, if it was x squared equals 3, we would take the square root of each side. So we don't, what we do in algebra, we would do to a trig equation. Square root of tangent squared is tangent x equals, now we have to remember here, because we took the square root, it would be positive or negative square root of 3. And so we have to go to our unit circle here now and start looking at not only where the tangent is positive square root of 3, which most of us get, but sometimes we forget about the negative part of this square root. And so where does this occur? Well, positive square root of 3 occurs at pi over 3. Negative square root of 3 occurs at 2 pi over 3. And from there, we can go and give our solutions. What I would say here is this. X is pi over 3 and 2 pi over 3 plus pi n, plus or minus pi n. And so, big difference here. We have pi n versus 2 pi n. And I think one of the things we have to remember is tangent had a period of pi. Tangent and cotangent have a period of pi, so they're going to repeat every pi, versus sine and cosine repeating every 2 pi. And so I'm glad we did a tangent problem here. I didn't think about it going in, but there is a big difference in that property. All right, now here's one. 2 times cosine squared of x minus 7 cosine x plus 3 equals 0. To me, we could almost think of this as being, as an algebraic expression, 2x squared minus 7x plus 3 equals 0. And as I look at that, I'm going to, if I was dealing with this algebraic expression or equation, I would look at factoring it. 2x and x, 3 and 1, and then let's see, sign-wise I'm going to have negative and negative, and so then at this point then we would say 2x minus 1 equals 0, or x minus 3 equals 0. And so there's our zero factor theorem, and so then x equals 1/2 or x equals 3. Now, there's the algebraic counterpart to what we have to do to this equation. And so we're going to think of this cosine x as being the x in this statement here. And so we need to recognize this equation as being factorable, just like the algebraic one below it was. And so it factors into 2 times the cosine of x minus 1 times the quantity cosine x minus 3 equals 0. And we still use our zero factor theorem. 2 cosine x minus 1 equals 0, or cosine x minus 3 equals 0. And so now at this point, we have 2 equations to solve, and so this we would have cosine x equals 1/2, or cosine x equals 3. Well, right off the bat, I'm going to come over here, and there's no solutions to that part right there. Can anyone tell me why? hopefully we recognize the fact that there's no value of cosine that's equal to 3. And so there's no solution to that part of the equation. And so then we can come over here and cosine x is 1/2. And so where does that occur? Well, that's going to occur at, well, let's go to our unit circle. Where is our cosine 1/2? It's going to be at pi over 3 and negative pi over 3. Or, I guess you could also think of that as 5 pi over 3. I don't care which one of those two you pick, because our notation takes care of the other. So x in this problem is going to be pi over 3, 5 pi over 3, plus or minus 2 pi n. And so that generates all the possible solutions. And just to show you, 5 pi over 3 minus 2 pi gives us our negative pi over 3 that we could have also included. And so try not to be redundant here. It is also possible that we may need to be able to use one of our identities. One of the things I notice here when I look at this trig function is I have 2 times the angle for the sine and only x for the cosine. These need to be consistent. And so we do know that we have an identity where I could take this double angle and make it into a product of single angles. And so my identity for the double angle for sine is 2 times the sine of x times the cosine of x minus cosine of x equals 0. And once again, I can't say this enough. If you're not sure what to do when you're solving a trig equation, think of it as an algebra equation. If I looked at this, I would look at this as 2xy minus y equals 0. There's a y common to both, so I can factor that out, and y times 2x minus 1 equals 0. And so if I use that same property over here, I'm going to rewrite this as cosine x times the quantity 2 sine x minus 1 equals 0. And so now I have a product equal to 0. And once again, remember, if a times b equals 0, a equals 0 or b equals 0. And so cosine x equals 0 or 2 times the sine of x minus 1 equals 0. And so where does this occur? Well, we're going to have multiple answers for this. And so cosine of x occurs at, alright, let's see. Go to my unit circle here. My x coordinate is 0 at x equals pi over 2 and 3 pi over 2. Sine, now I have to come over here, and sine of x equals 1/2. Where does that occur? Well, sine of x is 1/2, occurs at pi over 6 and 5 pi over 6. And so there's my 4 solutions within my first cycle. These two came from cosine x equaling 0. These 2 solutions came from the sine of x equaling 1/2. And now we finish off the rest of our solutions by adding 2 pi n in.